Welcome to Off Hours, a conversation between Jon Edwards and Chris Manning.
So a bit of follow-up from episode 3, when I was talking about casting. There were a few things that I realized as I was editing it, I didn't really explain very well. So one of the things when you had asked about how to make sure that there's no air pockets in the flask when you're casting. But getting rid of air pockets actually starts before you cast. When you're making the flask itself and you're pouring the investment plaster in, you want to ensure that there are no air bubbles in the work at all. And so because the investment plaster is quite thick, think of it like a thick porridge when you're pouring it in. You get small air bubbles that attach to the models and don't want to just come off by themselves. It's not like water where it's liquid enough that the air will just come out. I use a vacuum chamber to vacuum out all of the air from the flask. In the case of one of my flasks, I'll pour the investment plaster into the flask, put it under vacuum, and I'll leave it under vacuum for 5 or 6 minutes. And you'll actually see it boiling, and you'll see all the air pulling out of the investment plaster. And from there, it will then, it'll then set, but it won't have any air in there at all. And so that means that the investment completely coats and surrounds the part. If you don't do that, you can, when you do eventually cast, those little air bubbles have left a pocket that's attached to the part. And so you end up with these little tiny balls of metal that are attached to the edges of your pieces. And sometimes they're in the most inopportune spot, so they'll destroy a pattern because they've attached to the the workpiece that you've got. Dealing with air and air bubbles is kind of an important thing when you're dealing with casting, not just when you're pouring the metal, but also when you're making the mold to begin with. Now, one other bit of follow-up when it comes to watches from an earlier episode, we were talking a little bit about Eterna, and I was mentioning anybody at Eterna can get a hold of me to talk about the Model 39s. I've been going through the process of buying some prototype movements from them. Shouldn't say prototype movements. They're not prototypes from their point of view. They're part of their regular line of movements that they manufacture. But they'll be prototypes for me so that I can start working with them and experiment with building some watches around them. So it's been an interesting process of going through and learning, sort of learning the different options that are available to me in terms of the features of the movements, the finishes on the movements, how many I can buy at a time versus, one of the nice things with the Eterna is that I can buy 1 or 2 at a time if I want to. I don't have to buy 50 or 100 of them. The Model 39 range is quite impressive. They have something like 88 different variants right now, all sorts of different features in it, everything from just simple time to date to, a chronograph add-on to it. It's been an interesting process in terms of how they offer different options, like the date window, for instance. You can get the date window, typically you see it at 3 o'clock, but you can get the date window at 1:30, 4:30, 6 o'clock. So there are a bunch of different options there in terms of where you want that date window to show up.
Yeah, the positioning of the date window, with the exception of a big date, it's really just a matter of changing the printing on the date disc. So if you'll be making your own date discs at any point, you could actually put the date essentially anywhere you want, just based on how you lay out the numbers on the disc.
One of the interesting challenges, of course, when you're buying a movement from somebody like this is how do you distinguish your watch made with a 3955 versus every other company that's making a watch with a 3955. I know nothing about making watches at this point. Well, I shouldn't say nothing. I know very little about making watches compared to making pens in terms of figuring out what's customizable when you just haven't done it at all.
Well, I think the fact that you're starting with manually wound calibers versus the more common automatic versions right away from the back, you're going to have a different look than most other boutique brands or micro brands out there.
Yeah, that was important for me. I don't mind the idea of an automatic watch, but there's something sort of pure about the idea of a manual wound watch, something that you sort of have to feed yourself every day or every couple of days to keep it running. It's not just running because you're wearing it. But I also like the look of the manual wound watches from the back when versus the having the rotor for the automatic. So that'll definitely set them apart a little bit compared to what a lot of people are doing with them.
What'd you get up to at Silverhand Studios today?
So I've been working on getting my new workflow down for building pens and working on a new model of pen, working out the bugs in that, and working out the bugs of using my new CNC lathe for doing work. And I know it's not really a new lathe. I've had it for 8 or 9 months now, but I haven't really used it for doing any production work yet.
Is this the gang setup?
Yeah, this is the gang tool setup. It's been interesting getting that working and working out some of the bugs in it. I really designed it so that it could work well for sort of light metal turning and primarily acrylics. I do have a need occasionally to turn things like nickel silver, and nickel silver is very hard on the lathe. It's especially when drilling. So I've been having a lot of problems with that.
Does it clog the cutters?
It puts a lot of force on the drill bit, and it creates a bit of a shock every time the drill goes in. So when you're drilling, you tend to do peck drilling. So you drill in a little bit and then you sort of release. You take some pressure off of the drill bit, and that breaks that chip that you're building up. So you sort of go in and you peck in, and when people drill by hand, they do it naturally. You put a little bit of pressure on, then you release a little bit, and put a little bit of pressure, release, and whatnot. And it makes it easier to drill. Doing a CNC lathe, you have a peck drilling cycle where it simulates that. So you go in for a certain amount, pull back, let the chips sort of pull out of the hole, and then go back in. And every time it goes back in, that shock of the drill bit hitting the material again puts a lot of shock on the drive motor system. And so I've been having a lot of problems with that.
I don't recall seeing any sort of lubrication system. Are you lubricating it by hand when you're drilling, or?
Yeah, I don't normally need to do any lubrication or any flood coolant or anything like that. So in my typical operation, I just have no need for it. In the case of something like the nickel silver, or I've also been playing with some Damascus steel this week, and both of those require lubrication of some kind, preferably some sort of coolant as well, because they're so hard on your cutters. So I've upgraded to cobalt drill bits, and I do a little bit of apply some some cutting oil manually as I go, but it's not ideal. So anyway, this is one of the downsides of having a home built lathe like this, is that it's not really designed for doing some of these higher end functions.
Now, are you using the Damascus in a new pen design, or what are you up to with the Damascus?
When I was down visiting some friends of mine in Boston, Chris Blue, he makes a lot of Damascus steel and a lot of Mokume Gane, and he supplies raw material for the industry as well as making his own line of wedding rings and engagement rings and things like that. And he gave me a sample of Damascus when I was down there. And so it was a chunk, I guess, maybe 1.125" in diameter and maybe 2 inches long, which isn't very useful for me for doing anything. It's perfect for making a couple of rings out of, but for a pen, it doesn't get you very far. So this is made out of 316 and 304 stainless that have been fusion welded together. And so I took a torch to it, heated it up so that it was yellow hot, used a hammer, drew it out into a longer, thinner cylinder. So, took it from 1.125" down to maybe 650 thou in diameter. And then, that then turned into sort of a piece that was 3 3/4 inches in length. So it's enough for me to do something with. So I've been turning a barrel in the design of this new pen design that I'm working on. So I've turned a sample barrel out of that. So I'm gonna do some finishing on it and etch it next week and see how it looks. But hopefully it'll look good.
Nice. So this will be your first pen that you've ever made in Damascus?
I've made a few others for other pen makers. They didn't have the ability to turn Damascus, so I did a couple of pen blanks for people several years ago. They weren't very exciting. They were just straight barreled blanks that were being used on kit pens. And so basically all I was doing was just doing an OD turn down to final diameter and then a drill through the center so that it would fit the kit parts that they were using for it.
And for the etching side of things, do you have a go-to etch that you like to use, or do you just use acids you've got kicking around?
You can't just use whatever you have kicking around. Like, for instance, I have nitric acid in the shop that I use for various things, and that doesn't touch stainless steel at all. So in this case, you use muriatic acid, and that attacks the 316 stainless and etches it. And depending on how warm the acid is and how long you leave it in there, it will go from being just a very, very delicate etch, which really just brings out the texture. And it shows you the difference between the 304 and the 316. Or you can go for longer, you could go for 20 or 30 minutes, and you'd actually get quite a deep etch out of it. And that gets you quite deep into it. Actually, I should say that it's attacking the 304 stainless, not the 316. Muriatic acid doesn't attack it.
No, I've not heard of muriatic acid before. Do you happen to know what that's composed of, or is that like a brand name? Or
no, I don't. It's not a brand name. I don't remember what it's composed of. It's typically used in cleaning pools, and it's used for etching concrete. So you can pick it up at Home Depot or somewhere like that quite easily, because you typically use it to etch the concrete before you do other things to it. So, for instance, if you're going to pour concrete onto an existing slab, you can't just pour the fresh concrete down. It won't adhere to the previous concrete at all. Or if you're going to put a layer of epoxy or something like that onto concrete, you can't just apply the epoxy as is. You need to actually etch it a little bit, and it sort of gives it a bit of tooth, something to grab onto.
now, is this something you happen to have been researching for your project, building your new floor in your shop?
No, I remember using this years ago when I moved into this house, because the first thing I did was put an epoxy coating on the floor, and while I did etch the floor, I didn't do a great job of it. I was in a bit of a rush, unfortunately, and I had sort of 24 hours to be able to etch and then apply epoxy to the floor before I started moving things into it. So it didn't really have a lot of time to set up, and unfortunately most of that epoxy's come off now. But the problems with being in a rush when you're doing things like that when you're on a move, and of course I haven't gotten around to fixing it since then.
Have you ever used any gun bluing solutions?
I have, and I've never been happy with them. I've used a few solutions, and metal prep is the biggest part of it. You have to make sure that everything is really clean, everything's degreased.
Yeah, no fingerprints.
Oh yeah, no fingerprints. So anytime you're doing that, so I use Simple Green as a degreaser, and that allows me to take off most of the the grease and oils and things like that. And then I'll usually use something like a brake cleaner to really get in there and clean everything out. And at that point, I only handle with nitrile gloves on. I also find that the type of metal, whatever alloy is in the metal, has a significant impact on how effective the gun bluing is going to be. So, unfortunately, if you're depending on what it is that you're bluing, you may not know exactly what the metal is. And so I find that some gun blues just don't work well on certain metals, and you don't really know until you've tried it. I tend to prefer using time-tested method of heating the steel to blue it. So again, surface prep is important. You need to make sure that it's highly polished, that you remove all of the oils, and then you just apply a gentle heat to it, and you allow the oxide layer to build up on the outside. And as it gets hotter, it changes color, and you just sort of heat it to the temperature that you want, and it turns it nice blue. Now, in this case, I'm not going to blue this Damascus. This Damascus is all made out of stainless steel, so I want it to be sort of a high silver polish on the 316 and the 304 is going to end up being sort of a matte gray, very light matte gray. And so this is going to be a more subtle texture than what you've seen on some Damascus steel, where you've got one metal that's quite dark, and so you get a heavy contrast with it. This is going to be a much subtler contrast between the two.
So is this Damascus pen you've been working on, is this strictly a prototype, or is this something you'll actually be selling down the road?
It depends on how much work is involved in making them and how reasonably priced they are. There are a few people out there doing Damascus pens, and they tend to be doing sort of accents on the pens. So think about basically a high-end, it looks more like a high-end kit pen with sort of Damascus accents on it. And I suspect they're doing that because it's turning Damascus can be a bit of a pain, and it's a lot of effort. I'd like to do more. The irony is that the Damascus is actually more expensive than the silver that I use in making my pens. So it's not a cheap solution, and it's difficult to reuse.
It's surprising.
Yeah, it's because it just requires so much processing effort, right? Making the Damascus is quite time consuming, and I wouldn't do that myself. As I said, I'd get Chris Plouffe to do that. Chris has a great process down for making Damascus, and he can basically make it to what I need. So I'd get him to do it. But even then, turning it into something useful, I suspect I will make some, but they'll be rarer pens. I won't be doing a lot of them just because a lot of it I'll have to do manually. Like a lot of the drilling I have to do manually. My lathe just isn't happy with drilling out the stainless. So yeah, I'll probably do more. This one will definitely go for sale, and we'll see how it does. We'll see how much interest there is in it.
Now, we've been talking about Damascus steel for a little bit. I realize perhaps not everyone listening will be familiar with what Damascus steel is. How would you describe it visually?
Damascus is a layered steel. There are many different traditions of layered steel. The Japanese layered their steel to help drive impurities out of the metal. Various other cultures have done the same thing, and so you get these thin layers of metal. And in the case of sort of a Japanese sword, it's the same material. It's the same steel that's being folded on itself. And so you do get these fine layers, but there isn't an obvious layering, like visually it isn't obvious that they're layered. Damascus steel is an alternative where you're taking different types of steel, different alloys of steel, and you take flat bars and you weld them together, and you basically stack up multiple layers of different types of steel. You weld them together, and you get traditionally you'd be using it in something like a knife or a sword, where you then get the advantages of both types of steel. So one of them might be a lower carbon steel where it's more flexible and can handle shock better, but it's not as hard, so it doesn't get sharp. And then the other steel will be a higher carbon steel, so it can hold an edge, but it's more brittle and therefore doesn't take shock very well. So you get the advantages of both the sharper, harder metal and the softer, shock-resistant metal sort of melded into one piece. It also became quite decorative because you're combining these layers of metal together. You can then etch away one of the metals a little bit, and so you then reveal this grain structure. And depending on how you weld the bars together, what shape the bars are in, what you do to the bars afterwards, that all reveals a different grain structure in the metal. And so you get some beautiful shapes and grain out of it, and it looks very much like a wood grain when you're finished with it.
Yeah, it's a good way to describe it.
Yeah, and so the other tradition of metalwork that has a similar effect is mokame gane, which is a Japanese technique of fusing different metals together, and there'll be non-ferrous metals. So typically it's copper alloys, gold, silvers, things like that, brass, and you weld those together fusion weld those together in multiple layers. And then again, as you twist them, as you draw them out, as you distress it and reveal layers underneath and then compress it again, you then end up with this, with this grain structure that looks again like a wood grain. You can then apply different etchants to it, different patinas that will affect some metals more than others, and it will really bring out that grain structure quite nicely. So that Mokame is also another thing that I'm playing around with a little bit, and I haven't gotten to the point where I'm happy with what I've been doing with it. But again, it'll be something to add to the list. But it's again expensive to do because it's, along with Damascus, it's a very time consuming process. So it's very labor intensive to make it. And then you have the added problem with Mokame that you're also dealing with more expensive materials. With Damascus, 316 and 304 stainless are relatively inexpensive, particularly when you compare them to, copper alloys that have gold or silver in them, gold, platinum, palladium, silver. All of these metals that you're using in Mokame are quite expensive by themselves. And then you sort of layer a whole bunch of them together, and you then spend hours and hours turning them into this sort of sandwich. And so you've now taken expensive metals and applied a very expensive technique to put them together. And that's before you even actually do anything to it, right? You haven't even made anything at that point. You've just made a sort of your raw material. That's one of the challenges when I'm making new pens or when I'm designing new stuff is I can make pens out of nearly anything, but you have to balance out the cost of the material versus the amount of time and effort you're putting into making the thing.
Are you making your own mokumegane, or are you also buying stock mokume and then working with it?
I can buy stock mokame. Yeah, Chris also does stock mokame, and I suspect in the long term I'll probably buy it from him.
So what alloys are you working with for the mokume that you've been making?
There's a few different metals that I like. There's two Japanese copper alloys. One is Shibuuchi and the other is Shakudo. And one has a little bit of gold in it. The other one has a little bit of silver in it. And they look very similar. They look like a nice pink copper when you look at them. But when you apply different patinas to them, they turn these beautiful sort of brownish gray colors, sometimes almost a purplish color. And so they're quite striking in contrast to something like silver or gold. Also, when you combine things like palladium 500 and silver, both of them are white metals. And you would think, okay, two white metals together, that doesn't make a lot of sense. But there's enough of a difference between the two and how white they are. And you get you actually get a considerable difference in terms of how they look. So you can see that grain structure come out. It's quite nice.
Tantalum would be an interesting metal to mix in, but not particularly cheap to work with. See, they get that bluish gray sort of white metal.
Right. Yeah, the other problem that you run into is that you have to work with metals that are compatible, fusion compatible, because these are fusing at a molecular level. And so you need metals that are going to fuse together. So for instance, I know Chris has done some work with titanium in, I think it was a Mokame. And so it's a challenge to get the titanium to then fuse to other metals, between oxide layers building up and then just them not fusing sort of at a molecular level, because that's what you're doing. You're not soldering them together. Some people have done that where they've soldered the layers of metal together, but that tends not to produce a very good quality billet. Get separation of layers quite easily at that point. Whereas if you get a complete fusion weld between the two, then it's not going to separate it. It won't delaminate on you.
Yeah, well, tantalum being a noble metal, I would imagine wouldn't have much of an issue mixing with, say, gold or silver.
Yeah, you'd probably find something that can work with it. Yeah, there's usually some combination of them that would work. So yeah, it's just a question of sort of experimenting, and of course that's the problem, is the the cost of experimenting with these precious metals. It's not cheap if something goes wrong, right?
Mm-hmm. And it's not exactly easy to pull the elements that you're mixing in and back out and to separate them after the fact if something were to go awry.
No, and in fact, that's beyond really what I'm able to do easily. You can certainly pull, especially if you're dealing with gold or silver, you can pull those out of another metal quite easily. There's various acids and things like that you can dissolve gold or silver into, and then you can take that solution and precipitate out the gold or the silver. But at a small scale, in a small sort of shop scale, that's not really practical. So at that point, if you've screwed up a billet of material, you're sending it back to your refiner and having them do it. But of course, the problem there is that you're paying for them to separate out those metals and recover them. So, you might only get, let's say, 80% of the value of the precious metals back. So
yeah,
even if nothing goes right, and yes, they can recover the metals, but you're not getting the value back.
So what are some of the mistakes you've made or difficulties you've encountered experimenting with making mokumegane?
Well, the big one is not getting a complete fusion weld, and the trick with it is that you have to get the right temperature, and you have to get sort of the right force, because it's you need the pieces of metal touching completely. Like you need a complete surface contact between the two pieces. You can't have anything in between them, so they have to be perfectly clean. Again, degreasing and being very careful about how you touch the plates. And then in the few test pieces that I've done, I have sort of heavy gauge steel blocks. So think steel blocks that are like an inch thick each, and then 3/4 inch fasteners that are then compressing down those sheets. So I'll go and compress those, tighten down the bolts, then I'll put it in my 20-ton hydraulic press, compress them more, and then tighten the bolts more so that the bolts are completely tight. And then at that point, I can wrap it in stainless steel wrap, put a little bit of activated charcoal in there to absorb some of the oxygen, put that in the kiln. And again, depending on what temperature, what metals you're using, the temperatures are going to change a little bit. And then you're going to get that into the kiln for a certain number of hours to make sure that everything sort of fuses together. You want to make sure that you don't go too hot. Otherwise, then you get this puddle of metal in there, which isn't very useful. Once you take it out, you then have to carefully sort of compress the billet while it's still very hot, but you can't be too hard on it, because at that point you could still get it to delaminate quite easily. So you have to sort of gently compress those layers together, and then from there slowly work on annealing it and rolling it down and turning it into something useful. So yeah, it's a long process, and other than doing a little bit of experimenting here and there, I would never do a lot of production work with it, because it's like, in terms of making it myself, it's just too time consuming. There are too many variables. And, you've got guys like Chris Plouffe and Jim Binion. The two of them are probably two of the most knowledgeable people in the world for making Damascus and Mokame. And, I can go to them and say, this is what I'm looking for. Make it for me.
I believe my brother-in-law actually purchased his and his wife's wedding bands from Jim Binion.
Jim is an interesting guy. I met him. I've been chatting with him online for quite a few years, and but finally met him at the Santa Fe Symposium this past year. So I had a chance to chat with him quite a bit and hang out a little bit. And great guy, fascinating man, and does some remarkable work. And the thing I like about Jim is that he's very he approaches jewelry making from a very analytical standpoint. So he sits down and he's figuring out what's going on with the materials that he's working with. So he's done a lot of research into 3D printing resins, which has helped me out. As I think you've mentioned before, I've been working on using a 3D printer for printing master models that I can then cast from. And so Jim has done some good research into the different types of resins that are out there for using it, how to prep them afterwards and whatnot. So yeah, Jim is a great resource for people in the industry, and he also does some beautiful work as well. So
Someone else who I believe is also on the West Coast there. Just flipping back to Damascus for a moment. Have you ever seen the work of Bob Kramer and his knives?
the name is familiar.
He specializes in sort of Japanese style kitchen knives, but the grain structures that he's been able to achieve in a number of his Damascus blades is really quite fascinating, and it strays quite a bit from that wood grain look that you would normally associate with a Damascus steel. He's able to get almost like a checkerboard or almost like a tartan type pattern, some arrowhead type looks to some of the blades, and it's just really neat what he's able to do. But he makes all of his own Damascus as well. He's a master knife maker. Anthony Bourdain did a short series a few years ago called Rare Craft, where he would just venture around North America, sort of dropping in on people who are practicing some of these age-old arts. And then at the end of the show, he'd cook something using one of the tools that they're working with to actually make the physical goods. That
now that you mention that, I seem to remember seeing that episode, and I remember seeing the work that he was doing. Yeah. So with this kind of thing, there are ways of achieving different technique or different visual patterns in Damascus, and a lot of it really has to do with the preparation, how you're making your billets initially. So for instance, in a lot of cases, people start with a flat sheet. So it might be, let's say, a sheet that's 3 or 4 inches wide and let's say 10 inches long. And then you stack up a bunch of those sheets together, and they may be 1 millimeter thick, 2 millimeters thick, that kind of thing. And then as you compress it, you draw them out, and then you can twist those patterns. So for instance, you could take that whole thing and you can then twist it in various ways, and that's a common way of dealing with it. But you can also go sort of all out, and you can do things where instead of just doing a straight flat layers, you can do sort of a checkerboard arrangement where you've got thin strips side by side of different metals, and that ends up leading to very different patterns, and they look quite nice.
Well, once you finish up with these pens you've been working on, it'd be good to slip some into the show notes, even if it's well after the fact, for people who may listen to this at a later date.
Yeah, I'll make sure that there's a few photos of these pens. This is a new pen design that I'm working on. The barrels are being made out of various acrylics and celluloids, and the caps are being deep drawn from silver sheet and then engine turned. And there are a few reasons why I went with this design. One is that it makes a slightly lighter pen barrel. As you know, having used a few of my pens, the solid silver ones are pretty heavy, and so a lot of people prefer a lighter pen. So this was an attempt to make a pen that's a little bit lighter and easier to write with. It also reduces the cost, because now all of a sudden, instead of having 100 grams of silver in a pen, I can cut that down to 25 or 30 grams. So it reduces the materials costs quite a bit, and also allows me to use some interesting materials. I have some antique celluloids that I've been able to get a hold of, and so I'm able to use those in these pens and sort of experiment a little bit. And the pen barrels, because they're all different materials, I can do things like throw in a Damascus pen, and it sort of fits within that model line of pen. I'm not as strictly sort of governed by the design and the materials like I am with some of my other pen designs, where I have intentionally created them with, let's say, silver and yellow, and so all of the pens in that sort of series are all in the same sort of design. And then the other thing that this is doing is allowing me to experiment with deep drawing, where I'm using a hydraulic press to take a flat sheet of silver and turn it into a pen cap. And that helps reduce the amount of time it takes to make the pen cap. A lot of them I was either turning from solid stock or from a cast piece. So, close to being a finished diameter, but it was being cast and then turned afterwards. And again, that's quite time consuming and costly. So being able to deep draw it from a flat sheet, I use less material and it takes a lot less time.
So what distinguishes a vintage celluloid?
Well, there aren't actually a lot of modern celluloids, believe it or not.
Just by virtue of being a celluloid, it's vintage.
Yeah, in most cases, there are a few people who are doing who are starting to make some celluloids. Friend of the show, Paul Burberry, he does a lot of pen restoration work, and he's been getting into manufacturing some celluloid. So he's been experimenting with that a little bit, and I'm hoping to get some celluloid from him before the end of the year to start experimenting with. But the traditional ways of making celluloid make it very impractical to manufacture at any scale, and it's not exactly pleasant stuff to work with. Film stock was being made from nitrocellulose. It could be exposed and printed with various colors and patterns. Most of it was used for movies or still photos, but it's also very flammable and dangerous to work with. Even transporting and storing the film stock is dangerous. There were laws preventing transport of film stock on public transit, and movie theaters were at high risk for fires. The film stock would go up and tear through a building quite quickly. With making celluloid for a pen barrel, what you're doing is you're taking that film and you're printing it in the different colors and patterns that you want. And then you wrap it around a mandrel of some kind, so just a steel rod or whatever. And you wrap it over and over again in different layers and build up the sort of a tube of celluloid. And you then allow it to cure for 2 or 3 years. And once it's been cured, you can then turn it and form it into the pen shapes that you want. You do have to be careful with the swarf that comes off of it because it is quite flammable. So you do need to be careful with the with what comes off of the celluloid. So it was a very very popular before sort of modern plastics came around. It was a very popular material for making pens out of because it was quite colorful and you could do a lot of interesting things with it. And you get this beautiful depth from celluloid that you don't get from a lot of other materials just because it is so translucent. But because of the cost of doing it and because of the dangers of making it and working with it and the flammability of it, etc., pen manufacturers stopped really making celluloid for pens. And so, so there aren't a lot of companies out there anymore that are using it. And I was fortunate. I found a guy in the UK who had bought up a lot of pen material that had been found in a factory somewhere, like a warehouse or something. And so he had a bunch of it. And so I've got, sort of probably 12 or 13 feet of this vintage celluloid in different colors. And it's all sort of 70, 80 years old. Beautiful stuff. It looks gorgeous and it feels very different than modern plastics do.
And if it's made from vintage film strips, it's actually still on brand for you because it would at least microscopically contain those light-sensitive silver halide crystals all intermixed.
Thanks for listening to Off Hours. You can find detailed show notes at offhours.show. If you'd like to keep up to date with the show, follow us on Twitter @offhours. Jon can be found on Twitter @UnderTheLoop, and Chris can be found on Twitter and Instagram @silver_hand.
And the last time I saw you sporting a pair of nitrile gloves was actually walking into your backyard, and you were flipping wings on your barbecue, which I think was is a Kamado smoker.
It's a Kamado Joe, yeah.
Yeah, Kamado Joe. And you were flipping all your wings by hand. Would you mind enlightening planet Earth as to this brilliant means of flipping 40, 50 wings on a barbecue quite expediently?
I'm also a big fan of cooking and particularly of barbecue and pizza. So this is something I'm sure we'll talk about more of. And you've had the pleasure of enjoying some of my pizza and my barbecue. And a friend who was into competition barbecue, he was always, when they were doing competitions, they were always trying to figure out faster ways of dealing with things. And when you're handling large amounts of meat, you don't want to use tongs. It just takes forever to deal with, to deal with the meat if you're trying to sit there, especially if you're dealing with, 20 pounds worth of wings or whatever. You don't want to sit there flipping all the wings with tongs. And so what he uses, and what I've started doing is you can buy woven cotton gloves at Home Depot, any home improvement store, that are made for people doing stonework, and they're designed to protect your hands, and they break apart quite easily when you're working with it, but they do protect your hands from getting cut up and from some of the dust and whatnot. But they also act as a bit of a layer of insulation. I use the cotton gloves, and then I put the nitrile gloves over top of that to keep the cotton gloves from getting too gummy and whatnot from sauces and whatnot on the meat. So between the two, I can just sit there and I can go at sort of handling the meat with my hands. So I can pull off, let's say, a large pork butt or whatever by just grabbing the whole thing and lifting it up. I don't have to sit there trying to figure out, okay, how am I going to pick up a 12-pound pork butt with tongs, or with wings. I can sit there and I can quickly flip a whole bunch of wings all at once. And I'm not sitting there trying to flip each one of them individually with tongs. So yeah, it's one of the secrets of doing barbecue on a larger scale is don't use tongs. Use your hands, and don't just grab the meat with your hands because you'll burn yourself.